Next topic is in kinematics in one dimension is formulae for uniformly accelerated motion in a straight line. So the formula for uniform accelerated motion in straight line, these are the important formulas here. So these are equations of motions for uniform acceleration. Take note of the straight line. So there are three equations here: equation of velocity time relation, displacement time relation, and displacement velocity relation. So for velocity time relation, that is the final velocity is equivalent to the initial velocity plus the product of acceleration and time. So v of f represents final velocity, v of I initial velocity, a represents acceleration, and t represents time. So again, the formula for velocity time relation is final velocity is equivalent to the initial velocity plus the product of acceleration and time. So the next equation is displacement time relation. So displacement represents S. So the displacement is equivalent to initial product of initial velocity and time plus half the product of acceleration and time squared. Okay. So similarly, initial velocity v sub I, t represents time, a represents acceleration, and s is the displacement. Displacement velocity relation, this is the third equation, that is the square of the final velocity will be equal to the square of the initial velocity plus twice the product of acceleration and its displacement. So again, this is the final velocity v sub f, initial velocity, acceleration, and that is displacement. Okay, reminder again, these are the equations of motions for uniform acceleration in a straight line. Okay. So let's take this illustration 1.6. A particle moving with uniform acceleration from point A to B along a straight line has velocities v sub 1 and v sub 2 at A and B respectively. So if C is the midpoint between A and B, then determine the velocity of particle at point C. So let's say a particle is moving from point A to point B. So say this is point A and straight line, this will be point B. So just denote point A and this is denoted as point B. Now the initial velocity at point A is v1 and at point B that is v2. Now if C or point C is the midpoint between A and B, so midpoint approximately here, so let us denote this as point B. Determine the velocity of the particle at point C. So determine the velocity. I'll assume at point C, the velocity is v. Okay, and I say total distance at point A and B represents x, and from A to B, A to C is x all over 2 since it is in the midpoint, and C to B is similarly x all over 2. That is, this is the midpoint stated here. Now let us consider motion from A to C. So say uh, consider motion A to C. Consider motion A to C from point A to point C. Okay, so I'll use what are the given velocity and displacement. So with uniform acceleration, so that will give us velocity and displacement is given together with the acceleration. So that will be our final velocity. I'll use this equation. Initial velocity plus twice the acceleration and displacement. So final velocity, considering A to C, so final velocity will be V. So V squared will be equal to initial velocity of V1 at point A initial plus 2 acceleration is constant and S is the displacement between them, so that is x over 2. So this will give you v squared will be equal to v1 squared plus as I mean ax, so that is ax, oops, ax, ax. Let's say this will be equation 1. Okay, now I will consider motion from C to B. Point C to point B, because the motion of the particle is from point A going to B. So I'll consider C to B, this one. So the initial velocity now becomes V, final velocity is V2. So it's using similar equation. So this becomes final velocity, which is this one, will be equal to initial velocity plus twice the acceleration, and displacement is x over 2. So now, so this becomes p2 squared will be equal to initial v point c plus ax will be equation 2. Now, the two equation, v squared, this one, that one, and this one. So equation 1 is v okay, v squared will be equal to v sub I squared, 1 squared plus ax, and the equation 2, this is equation 1. Now equation 2 is equivalent to v squared plus ax equation 2. Now the unknown is determine the velocity of particle v, a particle at point C. So that is v. Going back to the previous, this one is the unknown. Okay, solving for v. Now solving for v. So from equation 1, I can solve for ax. So therefore ax is equivalent to v squared minus b1 squared. Now let's say this is 1.1. Okay, now I will substitute 1.1 to equation 2. So equation 2 is b2 squared. So b2 squared is equivalent to b squared plus ax. Ax is this one now. Okay, so ax will be this one. So that is ax. So ax plus b squared minus b1 squared. Okay, simplifying, this will give us b2 squared equals to b squared minus b1 squared. So solving for b, so this will give you b will be equal to square root of b2 squared minus b1 squared all over 2. So this will be the velocity at point C. Okay. Now, problem or illustration 1.7. So there are two trains, P and Q, moving along parallel tracks with same uniform speed of 20 meters per second. So uniform speed. The driver of train P decides to overtake train Q and accelerates his train by 1 meter per second squared. After 50 seconds, the train P crosses the engine of train Q. So find out what was the distance between the two trains initially, provided the length of each train is 400 meters. So there are two trains, let's say on parallel track. So let's say this is train P and this is train Q. This is 400 meters. Train is 400 meters. Let's assume this is also 400 meters. Now, initially, they have their distance. Assume their initial distance from each other is value of x. Now this is train P, and this is train Q. Then uniform speed of 20 meters per second, but the driver of P, this one, the driver of this one decides to overtake train Q. and accelerates the train by 1 meter per second. Then after 50 seconds, somewhere here, it overtake the engine of train Q. So what was the distance between the two trains initially? So this is the distance between them. I denoted it as x. Okay. Now, distance traveled by train P. So let us solve the distance traveled of train P. Let's say train P. Distance traveled of train P in 50 seconds. So that is displacement, distance travel, let's say using the formula of S, initial velocity multiplied by time plus 1/2 a squared. So this is the distance traveled of train P. Initial velocity is 20 and the time is 50 and 1/2 acceleration of 1 meter per second squared, and the time is similarly 50, that is squared. So the distance traveled of train P will be equal to 1000 plus 1200, so 2 to 50, so 2250 meters. That's for train B. Now for train Q, distance traveled of train Q in 50 seconds. So constant acceleration for a uniform speed for train Q. So similar formula, Q will be equal to initial velocity multiplied by time plus 1/2 acceleration multiplied by time squared. So initial velocity is 20 multiplied by 50 plus 1/2 acceleration. Is there any acceleration for train Q? So none. So this is 0 and the time is 50. So any real number that is multiplied by 0 is equal to 0. So therefore 20 multiplied by 50 is 1000 meters. Okay, now now their difference in distance SP and the distance traveled by Q will be equal to 2250 for SP, and SQ has a value of 1000. Okay, so this will give you 1250 meters. So now this distance, okay, this 1250 meters must be equal to the initial distance between the trains plus the length of the two trains. So that will be giving us 1250 will be equal to the initial distance between the trains plus the lengths of the two trains. So two trains, so 2 times 400. Okay, so this will give us x plus 800. Okay, so this is 1250. Then solving for x, that gives you 450 meters. So the initial distance between the two trains is 450 meters.